like to take a chance to introduce your presenters for the day, as well as myself. So I'm Stacey Witchin. I am the Grower Support Rep Lead. I joined Cargill originally in 2011 and have been working in agronomy and crop inputs. And my main passion is around supporting growers by finding opportunities to bring to them. I live with my husband, my daughter, and 3 dogs just outside of Purdue, Saskatchewan. Tracy Kinch is a senior market development agronomist. She joined Cargill just 2 years ago in 2021. She has a passion for genetics, sustainability in agriculture, and the constantly evolving world of biostimulants. Tracy, her partner, and her 2 cats now call Regina home. And last but not least, Walter Enns is our national agronomy lead. He joined Cargill in 2003. He has a passion for crop nutrition, sustainability, and biostimulants, and how these topics fit into crop production in Western Canada. Walter and his wife Phyllis reside south of Winnipeg and have 2 daughters, 1 son-in-law, and 1 beagle. Tracy and Walt have joined me to talk to you today about biostimulants in agriculture. Our discussion today will be on what are biostimulants and how do they work, what we have learned from using biostimulants in ag, discovering the biological that could fit best on your farm. Throughout the presentation, we're going to be using Mentimeter to get your feedback on relevant topics. You should see the code in the chat, but this code is for today is 8207-7761. If you do have any questions as we go through, please type them into the chat. And our plan is to leave 15 to 20 minutes at the end of the presentation for a Q&A, and you'll see me again. As a heads up, this call is being recorded. And without further ado, I'll pass the stage to Tracy for our first Mentimeter question.
Thank you for that wonderful introduction, Stacey. So I figure the best way to kick off this presentation is simply ask you guys what you think of when you hear the word biostimulants. So as Stacey mentioned, we're going to be using Mentimeter, and you can just go to menti.com. It'll come up on the top here on the next slide. And yeah, so we're getting some results already. There's a lot of discussion around the word biostimulant, and I'm curious how people interpret it. Some people have positive experiences. Some people are just getting into this space. I know it can be a bit confusing. So we can already see there's definitely varying ends of the spectrum depending what experience people have had with it, or just lots of curiosity here. All right, Walt, I think I will pass this to you next.
Thank you, Tracy. That's a great response from Mentimeter. You know, when we've been doing this a couple of different times, we've seen them. The main 2 responses are usually bugs and snake oil, and really interesting to see snake oil and seaweed. So really, yeah, thanks a lot, guys, for that. That's super interesting. When I think about snake oil, it definitely resonates with myself. As we've been diving into biostimulants, and we've been looking at a lot of different ones, the team's probably looked at 28 to 29 different biostimulants since 2019. And as you look at them, you don't always get the response that perhaps was written on the technical bulletin or the response that you see in the marketing data. And with the way that biostimulants are registered, there's not this strict protocol on research authorization, you know, the same as what we would see in a PMRA or the same with what we'd see with a crop protection product. a little bit of a looser protocol around that. And perhaps, maybe a little tongue in cheek, but perhaps, there's a little bit more marketing on some products compared to some of the science behind it. So, things to certainly watch out for. When I think about biostimulants, and maybe just a word or a caution, if you're seeing, going to the technical label and you're seeing things like proprietary blend, you're seeing things like beneficial microbes, or just simply the word mycorrhiza, I'd probably caution you to avoid those products. At the very least, sit down with somebody to walk through them a little bit deeper, just to find out what they're about. You should be able to pull a label on these products. You should honestly be able to see Latin names within these products, and that'll give you a good indication about, do I want to pursue the product further? Now, saying that, biostimulants, we certainly have learned a lot about them over the years. I mean, they've been, I started my career in 1991. They've been around a lot longer than I have, and so we use them in a lot of different crops. I'm not going to go into all the specifics, because Tracy, in the next slides, she's going to go into more specifics of where we use them and some of the Latin names and some of those things. But there certainly are some really good biostimulants out there, and we're learning more through our best management practices on how really to make the products use at their very best. And so, don't be disheartened. There's great products out there. Manufacturers are doing some fantastic things just through the scientific community on how they're actually putting biostimulants together, and how we're actually getting those biostimulants into the jug so that they are, viable. So with that, let's jump right into it. Biostimulants, they can be a substance, they can be a microorganism, but when they're applied to the seed, the plant, or the rhizosphere, they're really helping the plant's natural ability to improve nutrient uptake, efficiency, improve root development, improve shoot development, help handle abiotic stresses, and really help us increase our crop quality. As I said, we've been on this journey for a while, and 2019 is when we really started to dive in and look at some different products and do some testings in the fields. We've since then started to break down biostimulants really into 4 subgroups. And you might not have heard of other, individuals doing this, but as complicated as it is, it's necessary to really start to break them down to subgroups. Being in a few biostimulant seminars lately, and I've been traveling around a little bit, learning more about these. And just to give one example, 1 teaspoon of soil has more microorganisms in it than there are people in the world. And so now you're trying to unpack all of that. And just, in the Bacillus species alone, there's 250 species that, we've learned, within that group. And so there's a lot going on in it. And so hence why we've broken it down into these 4 subcategories of microbes, acids, extracts, and other. I'm going to go into more detail in future slides, but for right now, I'm going to leave it as that, just so that you guys are aware. And we'll jump into the next slide. Over to you, Tracy.
Thank you, Walt. So we often hear this term biostimulant, which is quite new. It was first found in scientific literature in 2027 or 2007 there. And so I just want to point out that biostimulants are not new to agriculture. We've been using them for many years. We've just never really used the term biostimulant. So maybe put a different perspective on some of these products for those who put snake oil, because we often think that with some of these new products come out, but not all biostimulants are. Jumpstart's one producers might be familiar with. It's Penicillium bali. It's a microbial that helps break down phosphorus bonds in the soil with calcium and aluminum. It's quite popular in areas where it's a little bit colder or you have some phosphorus bound up. Another common example we use in pulses is inoculants. I have leguminosarum on there just because I'm from legume country. But yeah, all inoculants fall under a biostimulant category. So it's just a little bit food for thought that not all biostimulants are snake oil, and just kind of have an open mind and see where we go from here. So I'm going to go next to another Mentimeter question. And it is, are biostimulants part of your current farming practice? Hopefully those who are growing pulses say yes now that I told you inoculants are, but I'm curious to see what others are trying. And even if you answer yes for pulses, I'm going to go into a little more detail in the next couple slides to give you a chance to maybe say what you're using on your farm. So it's looking pretty promising there, Walt. I'll pass it back to you to break down some of these subgroups a little bit more.
Thanks, Tracy. Okay. As I said, the four subgroups, I've got them here, and some of the work that we've been doing since 2019. I've put a few products into here as well, and bear with me as I click through some of these, and some of them will be quite familiar with you. There's a lot more products than this, but these are really our top 7 products that we're seeing within this space right now. And what we've sort of broke down. The microbes, as I have mentioned already, one of the subgroups. And this subgroup, really, the primary strength of this group is really that uptake of nutrients and efficiency of nutrient. And it's also root development. That's the primary strength. As those primary strengths, happen within a plant, then there's secondary, third, etc., things that do happen. And I'm not really going to go into those. Trace is going to go a little bit more onto each one of these categories and some of the details of some of the field tests that we have done. But I want you guys to think really fundamentally about these. And as you're starting to, potentially have them on your farm or decide which one to use, really think about microbes as being that nutrient uptake and efficiency and root development. That's truly its primary strength. In there, Tracy's already talked about the rhizome and that inoculum. And of course, that's one that we use a lot on pulses. Bionic is truly a PGPR. So it's a plant growth promoting rhizobacteria. And it's got a stacked approach to different trichoderma bacillus species. And it actually does have penicillin belli, in that product as well. And so just different ones that we can think of, and they really fit into that microbe. They're not acids, they're not other, they're not really into that extracts spot. So interesting how those work. The nutrition in Vita, those are endophytes. They really help with nitrogen fixation, and they really work on crops that don't typically fix nitrogen. I'm not going to go into more detail there, but just a little bit of information for you guys on how these microbes fit. All of those products in that space are microbes. Trace is going to share again some of the results from our field tests. Acids, their strength really is around shoot development. And one of the products that we had an opportunity to work with is Proliant, and it uses gibberellic acid. I'm not going to explain exactly how that works within the plant, but that's its primary strength is really through that shoot development. Extracts, an example of that is Olm. And these are really, when we think about extracts, one of the products one of the actives that's really well known is Ascophyllum midosum. There's one of those Latin names again. And Ascophyllum midosum really does help with that abiotic stress, heat, cold, chill, and how it can help the plant with those abiotic stresses. In the other category, these are normally nutrigenous compounds. And I'm just going to move my slide forward here, just so that you guys can see a little more about, what's written in red about each one of these. And the other category is so interesting with the nutrigenous compounds, proteins and amino acids or amino amides. One of the products that we had a chance to look at is Megaflow. I haven't put that one, on our slide. It's a really, really interesting product that fits into that other category. Precision Starter, I have it, not exactly in the bubble. It's just kind of outside of it. It absolutely does fit into the other category, but the reason that I've put it off to the side is because it has nutrigenous compounds, which really do help. So it's placed on the seed, really helps with the seed getting out of the ground. We've got that great pop-up effect. We've got that great shoot development. But the interesting piece around Precision Starter is it also uses an acid. It's using an IBA acid or a butyric acid, which also helps with shoot development. It's part of that category called acids, which really is important in that shoot development. So really understanding some of the subgroups, how, what are you trying to accomplish on the farm, and which one of them can actually give you the result, really enhance that plant's ability to naturally do these things. And so that's why I wanted to break them down into this way for you guys. We're going to go into more details of what we've seen in our field tests, but I'm hoping that this really helps break down what the subgroups look like. And when we start to, have different ones come across my desk, a product comes across my desk, that's the first thing I do is I break it down and say, okay, what is its primary strengths? What can it actually do for us? Then position it properly. Our marketing content that we get from, I wouldn't say manufacturers, I'd say distributors, sometimes is perhaps, saying a little bit more than what these products actually do. And that's why it's so critical in how we break this down and how we look at it. Tracy, I'm going to leave it right there, and let's dive into the next slide.
Thank you. So I'm going to go with my next Mentimeter question. It's the last one for a while. So what biostimulants are part of your current crop production? So we have microbials, as we had talked about, your inoculants, your bionic, maybe you've tried Nutrition and Vita. We have your extracts, so maybe you've had experience with Ohm or an Ascophylla nodosum product. We've added acids, so maybe you've tried Proliant, humic and fumic acid also kind of fall in that category, or maybe you're not sure what it is. You've tried a biological and you're not sure what category it falls into. Yeah, not much surprise on this poll here. We do have more experience long term with the microbials, especially with the pulses there and the inoculants. I'm really excited to see the acid there. Quite a few people trying it and some extracts. All right. So like I said, that's my last Mentimeter for a little while here. So I'm going to go down and break down each of these categories that Walt just explained here once I find my mouse. So first up is extracts. So Walt had mentioned extracts' primary strength is to handle abiotic stress. So that would be your heat, your little bit of frost, your moisture conditions, whether too much, too little, even salinity. So what extracts do is they contain plant growth hormones, amino acids. They contain polyamines, which are sugars, and oligosaccharides, which are fats. So what they really do is when a plant goes through a stressful period with abiotic stress, the photosynthesis starts to shut down because as you think about humans, we start to cannibalize some of our sugar and our fats. So plants do the same. They shut down. So what these extracts do is they help that plant keep producing sugar and get through that stressful period a lot easier. So Walt had mentioned Ascophylla nodosum, and it is the most commonly studied species in agriculture at the moment. It's kind of fascinating about seaweed. We've used it for centuries. It dates back to coastal regions in Ireland actually gathered seaweed and put it on their potato crop as fertilizer. One of the reasons you might say, why seaweed? That's a really strange thing to look at. So when we think about seaweed, it's being on the ocean and it often moves with tides. So it can go under deep water and be nice and cold and dark, or it can be washed up near the surface and be baking in the sun. So it incurs a lot of different environmental conditions. So seaweed innately has this ability to kind of regulate itself a little bit more under extreme stress. So that's why we're studying Ascophylla nodosa a lot. So one of the products we have been working with that contains Ascophyllum nodosum, the extract is about 97% in ohm, so it's quite pure Ascophyllum nodosum. And we've been using it on crops to help with abiotic stress, as I mentioned there. So both these photos were taken by Ryan Melbeck and MDA out of the Rosetown Kindersley in 21. So as you are aware of, it was quite a drought year. So these results are quite exciting to see how the plants responded with the stress conditions. So on the left there, we have some lentils that are looking a little more yellowing, a little less root growth, and you can see how the ohm really helped it handle with that heat and drought stress. And then we have canola on the right there, and you can see in the treated photo or treated side, the plant had larger leaves, the plant were taller, and it lost less of its flowers due to heat stress or heat blast. So I'm really excited about ohm and even Ascophyllum nodosum to really help handle that abiotic stress, because all plants face stress throughout the growing season. So next I'm going to move on to microbials. Short and sweet, microbials are beneficial fungi and bacteria. And as Walt had mentioned, their main strength is nutrient uptake and root development. So I had mentioned two classes that come to mind, rhizobial bacteria, such as an inoculants, and also Penicillium belli, which really helps break that nutrient bonds in the soil. So those are kind of two of the most common ones. One that's really gaining attention, though, is endophytic bacteria. And we're really excited about this category, and especially two products that come to mind in this category are Nutrition and Vita. So these are both endophytic bacteria, and what that means is they move into the plant, into the living cell tissue, and they don't harm the plant in any way. What they do is they use this cell to help replicate their own bacteria. And the bacteria in these two products is a nitrogen-fixing bacteria. The one in Invita comes from a sugarcane plant, and it helps fix its own bacteria naturally. So we can use these products to help plants that don't naturally fix nitrogen, such as corn, canola, or cereals that are high nitrogen users that can get a little boost here from a microbial. So yeah, so that's those two there. So these are some of the field tests we've done with both Utrisha and Invita. We can learn as much from a negative impact of an application, sometimes as much as a positive result. I summarized some of our key takeaways from that one field test on the left there from carbon in some of our key takeaways. So I won't go much into theory of what happened there. I am really excited about the potential of these bacteria with some of the best management practices followed. As you can see on these graph here, over the 20 trials we've done over the 2 years, we had an approximate return of 4% overall the trials. So there's a lot of promise in these products when some of the best management practices are followed, because we do need to remember these are living organisms, so we need to treat them with a bit of care. And so I just want to point out, not every year had a response, which was something that was mentioned in the Mentimeter. Sometimes they can be a bit inconsistent. And if you look at the long-term results, I I would say 7 out of 10 trials is pretty good. But we need to frame biologicals with an open mind because we're still learning a lot. And I'll talk about that a little bit more in further slides. One I can speak to directly is an in vitro trial done in Congress. It's one of the yields that were negligible or insignificant between the two treatments. However, when we graded it, the protein was 1.5 points higher. So we might not necessarily look at protein all these trials. So maybe we do have more bumps compared to what's just on the piano graph here. So that's something to keep in mind as well. So the last category I'm going to kind of talk about is acids. So the main acid we've kind of been looking at in this category is gibberellic acid. It's a naturally occurring hormone found in plants. And what it does is it encourages plant cell growth, but not duplication. So what it does is it makes the plant cell longer. So you'll think about it when we have spaces between the internodes. Gibberellic acid is the one that really stretches those nodes further apart in cereals or corn there. So its primary strength is to promote shoot growth there. So it really makes those leaves a little bit longer, those stems longer. And fascinating fact, gibberellic acid was a key component of what many call the Green Revolution. So we had reached a point where with fertilizer, we could only go so far, and gibberellic acid played a part in it by allowing that more leaf material, larger stalks, and identifying that plant hormone. It's extremely important in the horticulture industry. They use it on dwarf plants, or they use it specifically on grapevines as well to really make those grapevines longer and more leaf material there. So you'll hear about it a lot in the horticulture industry. So this is one product Walt had mentioned we were working with gibberellic acid specifically. It's called Proliant. This field test was done in Camrose in 2020 on corn. So you can see the photo on the left there. The Proliant treated plant is taller. It's hard to see there, but the leaves are a little bit longer. And then as we zoom in the middle photo, you can definitely see the thickness in the stem. So that gibberellic acid really helped strengthen that stem, extend the internodes, and make those plant taller. I did want to call out on the right here. So when we talk about gibberellic acid, you might hear it in a different product, a different set of products such as Modus or Manipulator. And I just want to call them out because while they do impact gibberellic acid, they're not biostimulants. So what we want to remember is biostimulants encourage the production of this acid. So Modus Manipulator impact it slightly in a different way that reduces the gibberellic acid. So they do have a role in gibberellic acid production, but they're not biostimulants. So I just wanted to put that out there because we do often hear gibberellic acid when it comes in terms with Modus and Manipulator. Okay. So we've learned a lot about biologicals here, and these are some of our key takeaways as we've worked with them for the last couple years. And something I really want to point out that we might be familiar with some of these working with inoculant, especially number 5 there, like storing it out of sunlight, keeping it kind of cool. These are living organisms, and we need to kind of keep that in mind when we're working with some of these. I know it's a little bit easier in seeding, like to keep it on the trailer and stuff, but on herbicide timing, beware not to leave these on a sprayer trailer in the sunlight or in the shed. It's a lot hotter in season, so we need to take care with that. Number 4 there was something I had mentioned that's really key with endophytic bacteria. So number 4 says apply foliar biostimulants at a higher water volume. And so when we think of products like endophytic bacteria, they really need to get into that tissue to make a home. So products like Utrisha and Envita really require that water volume to cover that leaf material, because if you have a bacteria that needs to enter the plant stomata and you get it, say, only on the top leaves or even just on the ground, you're not going to get as much productivity out of the product if you would get nice even coverage through the canopy. So we always recommend high water volumes with biostimulants to give them the best chance. Number 3 is apply foliar biostimulants when conditions are favorable for good growing conditions. And that's something to keep in mind too, because these are living products and the plant needs to form a relationship with them. So even the plant needs to uptake that acid or that extract and get it into the plant. And so we don't want a plant that's already kind of stressed, because it's not going to use this biostimulant as effectively as it could if the plant's growing and healthy and has like even sugar for the endophytic bacteria. Some of you might remember Modus from 2021. When the plant shuts down because it's stressed, a lot of things don't have the same effect as they would if the plant's under good growing conditions. Number 2 is apply to crops that are managed for agronomic success. So we never want to say any of these products are a replacement for anything. They're not a silver bullet. We want to use biologicals and biostimulants as kind of an addition, a top up, adding something to our portfolio. Walt's going to talk a little bit later about a stacked approach. That's where we really feel these products have the best fit. So one question I get asked a lot with Nutrition and Vita is, or even other products that have claims, how much nitrogen can I reduce if I'm applying these products? Have we measured how much nitrogen these products are fixing? And the answer is it's a lot more difficult to measure that than one would think, because we're relying on a lot of other conditions as well. So we never want to use these as a replacement for anything. So that ties into number 1. It says use to enhance a well-balanced nutrient plan. So when we're adding penicillin bali to the soil, we're helping break that soil phos down, but we're still adding phos. You're never going to replace the nutrient that you put with the seed or the nitrogen that you apply with the crop. You're just giving it a little bit more of a boost. And that's one key message I think we should take away from that. All right. So this is now summarizing what we've learned from the last 4 years. So the last slide was kind of our best practices, and this is some of our key learnings. So a lot of times we get asked, what's the dollar value of using biostimulants? And it's a little more tricky to put a dollar value on some of these products. We really need to think of biologicals as a complex situation. We need to think about putting benefit on soil health, plant ability to withstand disease, plant stress health reduction, soil nutrient availability. A lot of those don't get economic dollar values. So that's why when I say ROIs are not guaranteed, we don't necessarily see the dollar value return, but we see a lot of return in other ways. We don't necessarily measure microbial growth underground. As Walt mentioned, there's a lot of microbials we don't know a lot about in the soil. So biologicals have an impact on that isn't necessarily always measured. So I just want to make that clear, that these products don't always have an economic return, but they definitely have an environmental return for sure. And you'll hear more about biologicals, I think, as we start moving towards I hate to say it, the cliche term regenerative ag or sustainable agriculture. These will have a good fit in building that soil health and that plant health. And the next one is rates and timings for biostimulant products have been shown to be crop specific and can result in very different crop responses. So this would be a call out to like saying, you're not going to put a nitrogen fixing bacteria on a pulse or something like that. You want to be specific with these products in your choices of what they're going on. Products like extracts that impact abiotic stress, all plants, like I said, get abiotic stress. So they're more of a broad stroke approach. But when you're looking at a product like an inoculant or a nitrogen fixing bacteria, there's definitely crops that will benefit more from that than using a wide stroke approach on those products. And then the last one is biostimulants are not meant to replace a complete nutrition package. I really want to stress this one because there is a lot of marketing out there with some of these products that because we're fixing nitrogen or we're breaking phosphorus off the soil, that we can really reduce our rates that we put down as fertilizer. And I really don't think that's the right approach to take. I really think these are in addition to the fertilizer that we're using to get successful crop. And I think that's my last slide. I believe you're up next, Walt.
Thanks, Tracy. Okay, where do we go from here? And Tracy broke down each one of those products from a subgroup and what they do, and went a little bit deeper into each one as well. So hopefully that gives you guys a really good idea. Tracy also touched on a stacked approach, and I'm going to talk a little bit about that in our biostimulants that are in the marketplace today. But I'm going to talk also about a systems approach and biostimulants that are coming down the pipeline. And then what I'm going to do is I'm going to go a little bit deeper into some of the field tests and some of the products that we're going to be looking at not only this year, but in coming years. So as I said, a bit of a stacked approach in our microbes, in our current state. The stacked approach really is you've got different microbes, and so you might have an amylocophasis, you might have a subtilis, you might have a trichoderma that's actually within that jug. But within that jug, we're getting a good result from the product. However, one of the products that's in the jug, one of the actives that is in the jug is really there for the benefit of the other microbes, so that their CFUs, or the amount of product that's in there, stays at a higher rate. So they're really becoming a food source. And so it's kind of an interesting approach, but it keeps the jug, if you will, healthy. It keeps the microbes really in a good spot. As we start to look into a more of a systems approach, and as we're moving into the pipeline, what we're seeing is that they're really understanding how these biostimulants, how these different species, whether the bacillus species or trichoderma species, how they actually interact with each other and how they can bring benefit to. And so one of the exciting ones that's coming up here is Bacillus valzensis. My tongue got a little tied up there. Bacillus valzensis. And the interesting thing about that product is it's coming from 3 different bacillus products, or actives, and it's moved into this one complex group. And that group, they've uncovered, or they've discovered that it is really helping with phosphate uptake. And so that was just one little thing on a systems approach. Now, all of a sudden, taking that same systems approach and then adding in something like subtilis and amylocophasis into that same jug, now all of a sudden we're getting the ability to use a bit more of a systems approach, and we're widening the amount of nutrients that we can help that plant take up. And so now, instead of it just being specifically on phosphate or just specifically on nitrogen, now we've got that ability to look at the macronutrients and the micronutrients and how we can enhance that plant's natural ability to take those nutrients up. Again, Tracy said, this is not a replacement for good nutrition. But if you've got this ability to add a biostimulant just to help ensure the plant has everything that it needs to pull on those nutrients that are there, that you've placed there, it's giving us a much better result. And so really excited about that systems approach and what's happening in that area. Our endophytes, our fungal endophytes, Tracy did a lot of explanation about that with our Utrisha and our Invita. The mapping process that's right now going on in that space in the scientific community is quite interesting as well. And we're starting to look at biological nitrogen fixation, so BNFs. That's going to be coming down the pipeline. Yes, nutrition and Vita are part of that complex, but stay tuned. More to come in that space, more interesting things to happen in that space. And when we really look at that live microbe, nutrient enhancement, root growth, with a systems approach, we're really looking now, how can we enhance not just the nitrogen, but how can we enhance nutrients in general? So stay tuned, more to come on that one, but that's exciting coming down the pipeline. You can see on my screen here, I've got a bar that goes from shelf life increasing. And typically with our microbes, we've got about a 3 to 6 month time period until, those microbes no longer are active, or they're not at a CFU level large enough that they can make an impact. And with this increase in shelf life, now we're seeing it go from 3 to 6 months all the way up to 2 to 3 years. Not yet in the microbial space, although that is increasing as well. We're seeing that a lot more in our extracts, acids, and other. Before they have to go back into the manufacturer to be recertified, we're getting a lot more years out of them. So that's very exciting. From an acid perspective, we've got pedolic acid that is now being used for nutrient efficiency. Typically, we would not see that in an acid. We'd only see that actually in our microbes. And when we combine our pedolic acid with a molecular compound, now we're not only getting nutrient use efficiency, we're also getting photosynthesis uptake. And so we're getting better chlorophyll, we're getting better health to the plant. So going down, further into what this looks like in the future, it's quite exciting, because that other category is opening doors that we typically would not have seen in our traditional spaces. And so we are going to be doing more work in that space. We've partnered with a group out of the UK, and we're going to be having field tests specifically with molecular compounds and pedolic acid across Western Canada. We're going to be using third-party research for that. It's not at the level yet where we're comfortable going commercial or comfortable going to the farm with it, but we're quite excited about what this could offer, and we want to explore it further. So we're using some third parties in Western Canada. I'm also working with a group out of Fort Collins, Colorado, where we're going to be doing some testing in the greenhouse and testing in small plot. And this is one of the products that we are working with. The next group is extracts. And in the pipeline, we've got some interesting things around pod shatter, and we've got some really interesting steps around abiotic stresses. And there's getting to be a little bit of a chatter in the industry and in different publications from a news perspective. And Ascophyllum nodosum is a big part of that. I'm not going to go into the product names. We're just not ready yet to say that. But Ascophyllum nodosum is quite interesting because of not only where does it come from, and Tracy went into the seaweed and what that looks like, but as you go into that extract, so where do you take, or where do you extract the active ingredient from Ascophyllum nodosum, and then how you actually put that into suspension in the jug, and then what rate and what timing you actually apply this at, you can get different results. And one of the results that we've seen lately, and this also comes to us from the UK and now is starting to come across Western Canada, is an earlier application on canola. I can all of a sudden have Ascophyllum nodosum going through the tissue into the plant as pod development. So as elongation happens, as pod development happens, now all of a sudden, right where the dehiscence zone is, or the two valves in the pods actually attached to each other, that area right there is called the lignin. And Ascophyllum nodosum has the ability to strengthen that lignin so that we can mitigate the risk of pod shatter. So it's not going to be like, one and now you've just solved for pod shatter, but getting some really, really interesting results. And that's a product that we will be using this year. Perhaps you're one of the farms that is on the call today that we're going to be doing that field test with. It's going to be small strip trials this year, but really, really excited about what that can do and what that might look like. And then how can we actually bring it into the pulse market? In soybeans, for example, if you've got 4 seeds per square foot, you're talking about a bushel of seed that you've lost. Can this Ascophyllum nodosum in earlier stages of application, as it's going through the plant, can it actually help with that? And so that's exciting, and we're looking forward to that. From abiotic stresses, there's some interesting things that are happening in there as well, with where we're extracting from and how manufacturers, not necessarily distributors, but manufacturers are putting that into suspension on how it's helping as well. So stay tuned on that one. Quite excited about it. The other I already talked about, that molecular compound combining with pedolic acid. But what I do want to emphasize there is that systems approach to really enhancing crop production. And so it's no longer just about that one nutrient. It's becoming that crop enhancements part of it. So again, stay tuned, but a lot of exciting things in the pipeline, a lot of exciting things that are happening, and some good partnerships being developed. With that, Tracy, I'm going to pass it to you.
All right, so I'm gonna Walt's gonna wrap this up, but I have one last Mentimeter question to kind of finish us off here. It's, what biostimulant are you most interested in learning more? So Walt had given a really exciting product down the pipeline with Ascophyllum nodosum and canola pods that I'm personally most excited about. But acids is up there, and even microbials. If you are really interested in Utrisha and Vita, or what else is coming down the pipeline, I'm just really curious. It's exciting to see such a difference between, or excitement in, all these categories, because not all of these is going to have an impact across the board. So I'm really excited to see the excitement here. And it's wrapped up, so I will pass it back to you, Walt, for our key takeaways.
Thanks, Tracy. Just going to advance the slide here. There we go. Okay, so we do have some homework and some actions for you guys. As Tracy and myself are putting this presentation together, I think, you probably can all tell on the call, we're pretty excited. We're pretty excited and passionate about this topic. Do we have all the answers? No, we certainly don't. But we've sure learned a lot since 2019, and this space is ever changing. We came up with these actions, or this homework, for you. 1, we want you to reach out. 2, we want you to make a plan. And number 3, we want you to use biostimulants. So what do I mean? So reach out to your MDA, learn more about biostimulants. Where do they fit on the farm? There's a lot of hype around marketing right now. Sometimes it's hard to figure out, okay, which one should I use? How should I use it? There's 5 different actives in the jug. Are they actually helpful? Is it a stacked approach? Is it a systems approach? There's so much going on. And so, please don't shy away from it. Don't be scared of it. Please reach out to one of the members of the team. We're more than excited to sit down with you. We might not have the answer, but I guarantee you we'll press forward. We'll find answers. We'll connect with people globally to find out what's happening in that space. So number 1, reach out. Number 2, make a plan. Make a plan at minimum by the crop. Details do matter here. Just as Tracy said earlier on with the pulses, you wouldn't use an inoculant that you use for pulses for nitrogen fixation with a wheat crop. You would be very, very specific on what that looks like. The same is true with some of these other ones. Yes, there are some general ones that can help in different situations, but it's really important to stick to those fundamentals. What fundamentally are each one of them doing? Why did we break them up into the subgroups? Why did we talk specific about their primary strengths? And so really start to think about that and what that looks like. The last one, of course, is use. And we really like to encourage you using a systems approach to enhance that crop production. And so if you're using, let's say an inoculant right now on pulses, and you're not considering a bacillus species, you're not considering amylophaceans, or you're not considering valsensis, I'd encourage that to happen. This is a way to help enhance that nutrient uptake. We know with our pulses, yes, we have to use an inoculant in order for them to take up all the nutrients that they need. I'm in Manitoba. I'm south of Winnipeg. We grow soybeans in this area. I need like 200 plus pounds of nitrogen available to that soybean crop so that it can get to full production and we get a crop off of it. But not just soybeans, all pulses, they're huge users in phosphate. They're huge users in potash. What's one of the biggest challenges that I have? I'm really challenged with how much phosphate and potash that I can put down. Okay, so I can spread it on. I can do things in advance to make sure that I've got the nutrients there by the time that I'm growing soybeans or pulses. However, if I'm using a little bit of a systems approach, now all of a sudden I can aid that plant's natural ability to pick up the phosphate. I can still look at that starter. I've got to be really, really careful with the starter because of how sensitive pulses are to phos and absolutely sensitive to potash. Seed row safety is so important there. But now all of a sudden we've got this ability to naturally enhance that. So really look at that systems approach and use. So I'm going to wrap up just by saying, want to encourage the homework, want to encourage the actions. Please reach out, plan, and use biostimulants. Thank you very much. Appreciate. I'm going to send it back to Tracy, and I think we're going to open it up for Q&A.
I can hear the passion in both Walt and Tracy's presentations around this space of biostimulants. So we're going to dig into a few questions here. There's a couple in here around microbials, and so just going to summarize them a little bit. But soil microbes and the balance that we need to have in our soils, how much is what we're doing from a biostimulant standpoint going to impact the soil microbe balance, whether that's bacterial or fungal? What are your thinking on how that's going to impact what we see in the soil as far as a microbial activity level, Tracy?
I think it's going to have a very positive result. Like, it's hard to quantify, but an example I know we can relate to is inoculum. I know we have been building these populations in areas that have been growing like peas or lentils and putting inoculum in the soil. And we can see that because when we grow non-native ones to Saskatchewan, like soybeans, we don't get quite the response in the soil we would as if we'd been building that population over time. So I'm really excited to see that kind of build up if we start using a Valensis species or something like that over time and giving that population a chance to build up like we have inoculant for using it for decades.
And how would that compare to native prairie that's been relatively untouched and we really haven't hurt or impacted the soil microbial activity there? How would what we're doing today compare to what nature looks like?
That's a tough one. I would say some of these species are not necessarily in high population or maybe not native that we're adding a bit like some of these inoculum species, or maybe we're bringing a balance where some of these that we have low population of will give it a shine in a synergistic response because some of these do feed on one another. So that relationship will build as we start adding it. Walt, would you care to add to that?
Yeah, well, you're spot on, Tracy. When we look at the natural ability, all the biostimulants that are in the industry, the manufacturers are working with, they're really coming from the soil. You're spot on, Tracy. They come from all over the world. And so sometimes they're not necessarily right, coming from our soils. but they are really enhancing that plant's natural ability, and they're really enhancing what is going on in the soil. I see it as a benefit too, and not a genocide going on, because I've introduced this one to that one. One of the things that happens in a regulatory, and there's, I won't go too deep here because I want to make sure we've got time for other questions, but from a regulatory perspective, it's really critical. The risk to health and risk to environment has to be assessed, has to go through the CFIA for these products to be registered in Canada. And if that can't be done, if that isn't proven, then they're not allowed. And I know I was working on a project out of California 2 years ago. It got stopped at the US border. We were not allowed to bring it in because that work had not been done. So it's very stringent, it's very strict, and it needs to be.
Excellent, thank you. Question here around the best timing. This one's specifically on extracts, but Tracy, would you mind talking through a little bit on best timing?
So there's kind of two thoughts here. So often we think about extracts like helping with abiotic stress. Some producers or some researchers believe adding it after will give you a benefit because it'll really help that plant respond from that abiotic stress. I like to believe that putting it on earlier, kind of as a preventative measure. So if you're giving that plant already the opportunity to prevent and respond from that abiotic stress, I think as it occurs, the rebound will be faster. I kind of liken it to like a multivitamin. You don't take a multivitamin like knowing you're going to get sick. You take it to ward off sickness. So I think in my mind, that's the best play for an extract there is by building that, the polysaccharides, the sugars in the plant that really helps the plant deal with stresses, even minor ones as they come up, which might not show the stress response.
Great, thank you, Tracy. I've got a good one here that I think gives a little bit perspective and helps around the expectations piece. What would be the top reasons why a stimulant might not work on a farm or in a field? This grower gives the first example, which is the stress wasn't there. But what would be some other reasons why we maybe wouldn't see an ROI or an impact when using a biostimulant?
So the biggest one that comes to mind for me is drought. Just because you can have all the nutrients in the world, but your plant doesn't have moisture, it's not going to grow. So when we look at the field tests I've done in my area, which is southern Saskatchewan, it's been under drought for the last couple of years. So I know they haven't had the opportunity to shine. So I think that would be key for mine. Um, yeah, that's the key one that comes to me is just moisture. Or even if you're putting a biostimulant in, I know also in my area I had some good moisture where it didn't have the stress, so you won't see that impact. Walt, do you have another one that comes to mind?
Yeah, I think maybe to add to it, that application timing, right? And so we've had a few that we've been working with. We got into some heat, we got into some wind. All of a sudden, we're doing a foliar application, and our foliar application really dried out before that plant could really take it in. And so all those things that you think of on good herbicide application or good crop protection application, they're also important in biostimulants, especially with those foliars, making sure that that plant can really bring in and before it dries off. Because if it dries off, you've actually baked those microbes. Most of them in that case are microbes, and that can cause a problem. The other one perhaps could be is a little bit of the marketing play on it, a little bit of the tech bulletin has gone a little bit of a marketing style instead of really holding true to the primary strengths of the biostimulant. And perhaps the biostimulant wasn't really going to help with that specific need that you had.
Thanks for that. I know we're just about out of time here, but I kind of want to piggyback one last question on Tracy's drought response, which I think would be very timely. Grower is wondering if there is any water use efficiency focused biostimulants, if that is something that anybody is doing any work on.
Not to my knowledge. I know there's been a lot of studies lately done on micronutrients and water uptake. So the biologicals that could have an impact on micronutrients, such as your molybdenum, your manganese, all those. I think any with the root impact. So some of the rhizobacterias or the bacillus, I think in theory they could have an impact on water use efficiency, just because we're seeing that impact of having, bigger roots, finer hairs on the roots. Those do impact water use efficiency. It's not, to my knowledge, been studied, but I do see a play there that it could have an impact.
Thanks, Tracy. Anything that you know of, Walt, coming down the pipe?
Yeah, thank you, Stacy. I'm not aware.
Okay.
It's a huge topic globally. People are looking at it all the time, and not just in the biostimulant space. They're really looking at it from a genetics perspective, just on how that plant, comes together. I think the only thing that I would add, and really, really wonderful, Tracy, like I agree with everything there. If we really think about a plant and how do we get it to, we think back to our best management practice and really think, how do we get that plant to its absolutely best so it can get to its genetic potential? We think about that nutrition. We think about good agronomy. And then when we think about some of our biostimulants and they're enhancing that ability, and sure, we talked about the primary aspect of each one. However, if you think about all those things and also we get into a drought situation, that plant being stronger, the roots being more developed, the shoots being better development, will it be able to handle those times where we don't have ideal rain? And why I say it that way is because if we get a drought, in some of the situation that happened to us in 2021, it was just too much of an impact. It didn't matter what we did. We had some root simulators in the ground that we could actually measure how deep the roots went, how much water uptake they did. And we even, doing all of that, we could really see that plant was taking up more than the plant beside it that didn't have the specific biostimulant that we were working with. However, it wasn't enough to change the yield outcome because of how severe the drought was in that specific area. And that was by Saskatoon at the incubator farm and some of the work that we had done with Yara. So I hope that helps, but it's absolutely an ongoing thing, not only for Cargill, but for an industry.
We are going to have to wrap up here. Apologize for not being able to get to all of the questions. We do have your questions with your names, and so we will be providing those to your local teams to reach out and get you some answers on those if you need any more clarification. Also, just a note that we will be sending out the recording. You'll probably see it in your inbox, I think, Monday morning. So again, want to thank everybody for coming today and hanging out with us for an hour to learn about biostimulants in agriculture, what we're seeing right now, and also what's coming down the pipeline. And thanks again to Walt and Tracy for some great information. Have a great rest of your Thursday and a great weekend, everybody.